Hello and welcome. This is, well, I'm not sure. It might be an addition to the previous video, which has been obviously all about stars and the astrophysics. Or I might put it as a totally new video. I'll probably do it as both. So, hello and welcome to this video. This is all about black holes, and welcome back to this video. Just rubbed off the stuff on the board I had before, and we're going to go on and talk about black holes now. So in the astrophysics video, if this is the new video or whatever, I mentioned in that about the black holes were caused when the solar mass of the star, which has undergone the supernova explosion, which is after the supergiant, okay, if it's got a mass greater than 3, it becomes a black hole. And I just mentioned that a black hole, and I talked about the fact that not even light can escape this black hole, but after a certain boundary we call the Schwarz radius, then it can escape, okay, and I came up with a formula for that, okay. What we're going to be looking at today is I've just gone on a little bit more, and I thought I'd do another little bit about black holes, because that was a black hole. I said it was a black hole. That was a very, very generic interpretation of a black hole. Now, in this video, I'm not going to be doing a whole new chapter, as to say, in terms of, I'm not going to be introducing you to a whole new branch of mathematics. I'm going to be going over what black holes are, the types, okay, so how we define a black hole, where each of these types were formed, why we can't see them but we know they're there. That's kind of an obvious one, really. And then just as a bit of an interesting point at the end of the video, I'll just recap it off by saying, well, what would happen if a black hole was in our solar system and it was the same size as the Earth, same size as the Sun, and it was in the same position as the Sun. So basically we've just replaced the Sun with a similarly sized black hole. What would happen, apart from the fact we wouldn't be able to see anything because there would be no light? Okay. Anyway, so black holes. Now, what are they? Well, essentially black holes, what they are is they're very, very dense material, okay? Obviously, we know, as I said, that the black hole was formed when a giant star collapses. Now, that's one type of black hole. So, generally speaking, a black hole is just a very dense collection of matter. So, a very dense collection of matter. In other words, for each unit of mass, or each gram of mass or kilogram, it's very, very heavy. Okay, so it doesn't have to be that big to be that dense. In other words, it will drag everything in. That's why we get this huge gravitational pull, because obviously, it's the bigger the object, we generally say, is being attracted by the smaller object is being attracted by the bigger object. But really, what we mean by that is we don't just mean its mass, we mean its density. So a black hole is a very, very dense version of that. Okay, so it's a very, very dense collection of mass. Okay, which is generally considered to be from a big star, but as I said, that's just one type. So that leads us into say, well, there's different types of black holes. Now, more specifically, there are 3 different types of black holes, and they're all to do with size and mass. In other words, it's just small one, big one. It's small one, medium one, big one. But obviously, there's a bit more to it than that. But that's the essence of it. Okay, so the small. Sorry, I don't know these facts off the top of my head, so I'm just kind of helping this sheet thing here. So there's a small, the smallest, okay, and these are called, these black holes are called primordial black holes. Okay, that's just the scientific name that's given to these black holes. Okay, so they're called primordial black holes. Okay, and these black holes are about the size of a single atom. Oh, great. Single atom in size. But they weigh about the same, but their mass is the same as that of a small mountain. A large mountain. Is that of a large mountain, which you can prove my theory before about a very, very dense collection of mass. Okay, so a very large mountain. Okay. Okay, and that's the smallest, and it weighs the same as a mountain. You can't get any smaller than that, really. Okay, so that's obviously quite clearly the smallest. Okay, the next one up is obviously the medium type. It's the medium, and this is the one that is the most common. Okay, and because it's the most common, it's the one we assumed when we said, you know, it's where the big star has fallen. It's crumpled, okay, and gone through this explosion. Okay, so that's what we're talking about when we mean the medium one. But still, it's got about that one that we talked about is known as a stellar black hole. Now, that's not the thing that you drink, or, you know, if obviously you're over 18 when you drink that. Stellar black hole. It's double E-double-E-R. Okay, stellar black hole, stellar. Okay, so don't start writing about beer and cider or whatever in your exam. Partly because all this isn't in your exam, it's not in your spec. But I've just been stupid and looked at it. Okay, it's about 20 times the mass of the sun. So it's got about 20 times the mass of the sun. But its diameter is only about 10 miles. So 10 miles in diameter. And there's no real distinction in terms of, there's no real difference apart from the size between these the two types, and also the third one that I'm going to introduce now, which is quite clearly going to be the largest one. This is also known, this is huge, in the jump from the smallest to the medium is, or really, which is kind of, we class it as the most common, is fairly big. I mean, we're going from a single atom to 20 times the size of the sun. But this next one is just as big, if not bigger, jump. Okay, the mass of the largest black hole, which is also known, it gives you a bit of a key here, supermassive black hole. So it kind of gives you a bit of a clue there. Supermassive black hole. Okay, and this has the mass of about 100 million suns. Yes, that's right, 100 million suns. Okay, it's got about the mass of 100 million suns. And the diameter is that of a solar system. So, we'll go into a bit more about these in a minute. Equals solar system. Okay, but that is generally the three types of black holes that you will see in the world. Okay, but obviously we want to go into a little bit more detail about each of these. And the question that we're next going to ask ourselves is, well, where the hell did these all come from? Now, the smallest one is really, because it's the size of an atom, you can think of it being the smallest. It's the first one to be produced. Think of it like that. It's basically, it comes from the big, it was existing around the time of the Big Bang, okay? So it's thought to have been formed in the Big Bang. Okay? That's obviously just, you know, quite obvious that really, if you think about it. Okay, so formed in the Big Bang, the smallest primordial black holes. The stellar black holes are created when supergiants fall or collapse, go through a supernova explosion. So it's the production of this medium or stellar black hole, which is the most common, is the production that we talked about when we were talking about the black holes in terms of how they are produced. Okay, so in other words, it's produced when supergiants collapse, go through a supernova explosion. So supergiants, so it's when supergiants go through a supernova explosion. In other words, they collapse. So if you can't quite see that, but it's the only other colour pen that I have. Well, I could do it in the other colours, but whatever. Okay. So, how does the largest one be produced? Well, if you think about it, if it's the size of the galaxy, or sorry, the size of the solar system, then it can't have been produced after the solar system, because that would push everything else out and eradicate everything else. So obviously we know we can't produce or get anything else out of nothing. Okay, so quite clearly it's formed when the galaxy was. Sorry, why do I keep saying galaxy? Formed when the solar system was. Sorry. Oh. Sorry, one sec. I think I've kept trying to say galaxy because that's what it was meant to be. Sorry, I'll just double check for you. Sorry, it's galaxy, not solar system. I don't know what the hell I was going on about. So the diameter of the largest supermassive black hole is the galaxy. So the solar system would be the whole thing, for God's sake. Stupid mistake. So it's formed when the galaxy was. I do apologise. Stupid, I could stupidly make that mistake. Okay? So that's really the main bulk of the information there. Just classifying what the different types of black holes and how they are caused. But I just want to, that's all the writing I really kind of want to do. I don't want to do that much more because, well, that's all the key information. I don't really want to rub any of that off. I mean, I could have been a bit more neat and tidy with it, but where's the fun in that, right? Okay, so the next few things that I'm going to go through are talking about why we can't see black holes, but we know they're there, but you can sort of see them, and I'll go into a little bit about that in a minute. And again, we'll finish off with what happens if the sun was replaced with a similarly sized black hole in our solar system. Okay, so the first thing I mentioned was talking about how we know black holes exist, but obviously we can't quite see them. And obviously you think black hole, solar system black, so how the hell are you going to see it? Well, one of the main things, one of the main giveaways, is it has such an extreme gravitational force, which some conspiracy theorists say, oh yes, that is a wormhole, which you've obviously seen in Star Wars or whatever, but that's just a theory. There's no scientific proof behind that. I mean, I might do it in my next video, but I can be bothered. Anyway, okay, so we know they're there because they have such strong gravitational force. But we can also detect their presence by something else. Really want to write this down, but can't bother. I'll make a bit. I don't know. I was going to make a bit of room, but I can't bother. Basically, when these black holes are so strong, okay, well obviously they are, but if they're near enough to a star, okay, and they're strong enough, because obviously the small ones aren't as strong as the other ones, as the large ones even, but they can pull off the outer gases of other stars because their gravitational attraction is so strong. Okay, because as I said, not even light can escape up to a certain distance, so quite clearly it's able to pull other stuff, bits of gas in quite easily. And when it pulls this gas in, it creates something called sorry, let me get the wording correctly. Accretion disk. Yeah, so they pull off this gas from the nearest star and it creates something called an accretion disk. Now, an accretion disk is basically just the gas being pulled around the black hole because of such strong gravitational force, okay? And when it's pulled round, it's spun and spun, and obviously that generates a bit of heat interacting with all the molecules, and it heats up the gas to a very high temperature. And when the gas is at this very high temperature, because of the nature of the black hole and its characteristics and the atoms inside it and whatnot, it causes the gas to emit X-rays, okay, which are obviously picked up by space observers and telescopes or what have you, okay, because we talked about in the previous booklet in the Astrophysics, I think we were mentioning about, in the optical and non-optical telescopes, we were talking about X-ray astronomy, and that's the kind of thing that X-ray astronomy would pick up, okay. Now, that's the last of the main theory. This next bit, talking about what would happen if a black hole was replaced. Sorry, if our sun was replaced with a black hole. Well, absolutely nothing. The Earth would not be pulled into the sun, where the sun was, this black hole, because it wouldn't be strong enough. It's too far away, okay, to have an immediate effect. Obviously, we wouldn't be able to see any light or whatnot. Oh, they might have current supplies or whatever. I mean, apart from the fact that moving the sun is quite a messy business. nothing would happen. You know, we would still be dragged around in the same way because the gravitational pull of the sun is still very strong, and nothing would change apart from the fact we wouldn't have any light. Now, some people say, oh, well, will the sun turn into a black hole? Well, as we proved, well, almost proved, obviously the solar mass of the sun, because the solar mass is the mass of the sun, and if you're doing the mass of the sun relative to the mass of the sun, well, obviously it's going to be 1. That's quite obvious. And if it's going to, and if you apply that theorem to the, in the stars video, toward the end of that, we were talking about the classifications of stars according to their size, okay, in the life cycle. And we said between 0.1 and 1.4, they end up being a white dwarf or a black dwarf. Okay, obviously they generally end up being a black dwarf, but there's no proof. We very, very rarely see that because there are very, very few stars that are that old, okay, to enter that stage. Okay, alright, okay, so that's hopefully clarified a few things, and we're not all going to be sucked into a black hole when the sun dies. We just won't have any energy, so don't quite believe that. Alright, so thanks for watching. I do kind of apologise it's not been the most exciting, well, it's probably actually the most exciting video I've ever done, well, for me anyway. But I mean, it's not the most relevant in terms of theory. But I mean, we've been talking, it goes off pretty much what we've been talking about. It's just a bit more background to it. Okay, so thanks for watching. Hopefully it's been of some interest to you, and we'll see you in the next video. Whatever that is, or whatever it is.